This is Note-Taking Guide 3.6. We're going to talk about some special cases of factoring. We're going to talk about perfect squares, difference of squares, and sum and difference of cubics. The formulas are up here at the top. If we have a perfect squared trinomial, our first number is a perfect square, our last number is a perfect square. And if I square rooted the first number and square rooted the last number and then doubled it, it would give me the middle number. I'll show you what I'm talking about in just a minute. In order to factor that, we're going to square root the first number, square root the last number, and do it both with plus signs right there to get that to work out right. If the plus sign is right here, if it's a minus sign right here, they would both have minus signs. The difference of two squares is when we have a perfect square number and a perfect square number that are subtracted together. When we factor those, we're going to square root the first number, square root the last number, and do one with a plus sign and one with a minus sign. The difference and sum of cube formulas are right here. This just says if we have a perfect cube number plus a perfect cube number, we're going to identify our a and b values and substitute them into this formula. Same with this one, a cubed minus b cubed, so a perfect cube number minus a perfect cube number, follow this formula. And I will show you how that works as we go along. So I'm going to look at these numbers right here for just a minute, and I'm going to decide whether or not this is the difference of squares. And I actually see a problem right here on this problem because this 9 right here is not a square number, like it's not 2, 4, 6, 8. I can't actually identify that. So I can see that this needs to be changed to an 8. This note-taking guide is wrong. So change that to an 8 right now, and then we will I'll change that on my worksheet later. But we're going to work the problem like it's 16n to the 8th minus 9. So I'm going to square root the first number. The square root is going to be 4n to the 4th. And I'm going to square root the last number. The square root of 9 is 3. Because there's no middle term here on this, I'm going to have to write it as two different factors. One of them is going to be positive and one of them is going to be negative. So my answer is actually this right here, but if we wanted to check our work, we could totally FOIL that back together and make sure that it worked. So this would be 16n to the 8th minus 12n plus 12n, which would cancel, and then minus 9, which is correct. So my answer is correct. This next one is also a difference of squares. I can tell because this is a perfect square number and this is a perfect square number. When that happens, what I'm asked to do is square root the first number. The first number square roots to be 2x. So I'm going to put 2x in the front and 2x in the back of my sets of parentheses, and then I'm going to square root my last number. The square root of 25 is 5. To get my middle terms to cancel, one of them has to be positive and one of them has to be negative. This next one is a perfect cube. Again, look at the front. It can square root to 4b. If I look at the back, it can square root to 25. But what I need them to do is add up to a negative 40 in the middle. So what I'm going to do is put the minus sign here and do exactly the same term this time, including the negative sign. Because if I FOIL this back out, then I'm going to get the numbers that I need. This will give me 16b squared minus 20b, which gives me the minus 40b. And then negative 5 times negative 5 is a positive 25. So my answers in factored form would be here in the green. Okay, and that again, this is a perfect square. This right here can square root to 2x. The back number can square root to 1. If I put both negative signs on this because of the minus sign right here, when I FOIL that back out, I'd get 4x squared here, minus 2x, which would give me a minus 4x, and then plus 1. So this is my answer here in factored form. These next ones are sum or differences of cubes. Because of the plus sign right here, it tells me to use the formula a plus b, then a squared minus ab plus b squared. And I'm going to just identify my a and my b value and substitute them in. My a value comes from the cubed root of x cubed. The cubed root of x cubed would be x. My b value comes from the cubed root of 125. The cubed root of 125 would be 5. So every time I see an a, I'm going to put x in. Every time I see a b, I'm going to put 5 in. So a plus b would be x plus 5. A squared would be x squared minus a times b plus b squared, b being 5 again. Then I'm just going to simplify this to look prettier. The x plus 5 is fine out front. The x squared is fine. But I should write that minus 5x, not minus x times 5. And then 5 squared would be 25. This would be the factored form of my perfect cubed equation. The next one again is a perfect cube with a plus sign, which means my factor starts with a plus sign, and then it changes to a minus sign, and then ends with a plus sign. I just follow the formula. I'm going to identify my a value. My a comes from cube rooting the front number, which leaves me a. My b comes from cube rooting the back number, which would give me 4, because 4 times 4 times 4 is 64. Every time I see an a, I'm putting a in. Every time I see a b, I'm putting 4 in. So I'm going to have a plus 4, and then a squared minus a times b, b is 4, plus b squared, and b would be 4 squared. I'm going to simplify this again to make it look nicer. So I have a plus 4 in the front. A squared, that's going to change to a minus 4a. And then 4 times 4 is 16. So 4 squared is 16. This is factored form. Okay, again here, identify your a. My a here is going to be x from the cubed root of x, and the x cubed, and then my b value is going to be from the cubed root of 6. Well, 6 is not a perfect square number, or a perfect cube number. It doesn't actually work. So if that's the case, we're going to put not factorable. Because perfect square numbers would be like 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27. So this was not a perfect cube number, so we're just going to keep going on. All right, let's check this one. Can I cube root the u? I can. It would be u, because u times u times u is u cubed. And can I cube root the 8? I can. It's 2. 2 times 2 times 2 is 8. Because of the plus sign here, I'm going to use the formula with the plus sign in it. That looks like this. I'm just copying this from the other note-taking guide at the top, the other page. And then I just substitute it in. I'm going to have u plus 2. Then u squared minus u times 2 plus 2 squared, and I'm just going to simplify that. So u plus 2, u squared minus 2u plus 4 for my solution in factored form.